is Shegun Adeniji. He's an electronic design engineer at Philips. Shegun specializes in the design and development and testing of electronic boards for wireless communication used in medical devices. His experience spans across design and implementation of microcontrollers. He has a BSc in electrical electronics engineering and master's in microelectronics engineering from ULM Germany. Shegun currently works with Philips as a hardware development engineer in Germany. Shegun has a passion for imparting knowledge and has been involved in teaching and mentoring STEM students with passion and interest in STEM-related career. Please, can you make welcome Shegun? Can you welcome him in the comment section? Tell him welcome while I try to unmute him. Mr. Shegun, you're welcome. I'm going to try and unmute you now. Let's welcome him in the comment section. Just looking for him. Okay, right. Ask to unmute. So please, you can share your screen and
can you hear me?
Yes, we can hear you. I can hear you. They are muted, so they might not be able to. You can hear him. Can you put in the comment section, please? If you can hear him. Yes, can you put him in the comment section? You can hear him. Okay.
Could you kindly give me the permission to share my screen?
Yes, please go ahead. You can share your screen.
Okay. I'm having this comment: host disabled participants screen sharing.
Oh, you can try it again now again. All right. Okay. Are you the one trying to check? All right.
Yeah, I'm the one trying to do that.
All right. So that was me again while I just tried to get to your screen, but I would just just a minute while I try to sort it out. So we're just going to share screen. No, multiple participants. Maybe I should say multiple participants can share screen simultaneously. So can you try again now?
No, it seems to be working. Okay.
Is it working now?
Yeah, it's working now. Thank you.
Okay.
Let me know if you can see my screen.
I can see it. Can you let us know in the comment section if you can see the screen?
Please let me know if you can see my screen.
All right, so the answer is coming back. Yes, yes, seen. All right, so everyone can see the screen. That's beautiful.
Okay.
Yes.
Perfect. Thank you very much. Good evening, everyone. My name is Shegun Adeniji. I'm an engineer. I basically focus on the development and design, development, testing of RF products. So RF basically stands for radio frequency product. In my bio, you will see something with microcontrollers and microchips. Basically, microcontrollers are low frequency devices. So in the recent times, I moved away from low frequency into high frequency. So basically, I'm more of an high frequency person at the moment. So this evening, I will be speaking on the topic innovation and product design, and basically we'll just be looking at how engineering changes and redesign our work. Okay, so I do not have a lot of slides. I just have some very basic ones, and I will just be giving you some thought. I honestly do not know what your expectations are. It's been 2 full days of a lot of information. I'm sure you had a very good time yesterday. Unfortunately, I couldn't join the conference. I was just on my way from Abuja to Bauchi. So while the conference was going on, so I lost. I couldn't get any internet connection. I couldn't join. I was in the bus. I'm really sorry for that. But then this evening, I really enjoyed the moments, the time with Dr. Oyemi. It was a very interesting one. I mean, I'm also a very big fan of artificial intelligence, AI. This is the net important that we are talking about it. It's really important that we as Nigerians at the moment, we're also thinking in the direction that the world is going. I can see that my internet seems to be fluctuating. I'm really sorry. I'm in the north, and I don't think the network is really awesome here. It's not so great. I've tried
Just
like
go
two
on,
different sims.
Doctor. Just go
So
on,
please,
Shegun. We can hear you.
so please, if it disconnects, just um, kindly, please, I beg of you to just stay on the line, and it's going to reconnect again. So I'm speaking about my background. I'll tell you about a little bit about myself, what I do, where I schooled, and I will tell you about product design and development, what we are doing at the moment in terms of electronics design, especially in direction of high frequency engineering. And of course, I'll be giving you some few tips on what we can do as engineers to make sure that we get good electronics designs in the market. And we as Nigerians, how can we benefit from the latest trends and the latest technologies? And how can we make sure that we are able to design products that can compete with what our contemporaries in other parts of the world are doing? That is really important. I think that's probably one of the focus for this conference. Okay. Not to waste our time. So basically, I will tell you about myself. My primary education, I had it in Ibadan at Christ Mercy Primary Schools. I went from there again to another school, CSC Mapo Community Primary School, in the same environment in Ibadan. I then later proceeded to Muslim Grammar School, also in Ibadan, and later on to CSC Grammar School for my senior secondary school education. And I had my SSC exam written at a community high school called Obagba Community Grammar School. So I had my bachelor in electrical and electronics at Federal University of Technology in Akure, Ondo State. And in 2013, I moved to Germany to study microelectronics engineering at the University of Ulm. So I'm pretty sure that taking a look at my profile here, you can see that I'm coming from a very local background. Really, I think if I'm to take a look at how my education was, I didn't know that I would find myself where I am now, or I'll be doing what I'm doing at the moment. But one thing I can always say is that wherever there is a will, there's always a way. So I went to a very local schools all along, and of course, thank God for FUTA, thank God for University of Ulm, and here I am today. So I will go to just to tell you about my career. Basically, I mean, there were things I did before 2009, but I think what's for me much more interesting are things I do from 2009 onwards. So I did my industrial training at Radio Nigeria in Ibadan. I did my NYSC as a teacher, computer science teacher at the Holy Rosary College in Enugu in 2011. After I finished my NYSC, I couldn't find a job, and I had to work as an Indomie distributor in Enugu for a year, and after which I moved to Germany, and I started my master's in Germany in 2013. And during my master's program, I got a job as a part-time engineer, as a system engineer, in particular with Catrine KG. Catrine is actually a company that manufactures antenna. So they do different kind of antennas for different products, for radar system, for TVs, for satellites, So I was working on a project for them, which was later bought over by Ericsson. So after I left Katrai, I joined UL. I was basically working in Sony. Sony, you all know Sony. I was working in Sony. I was an electromagnetic compatibility engineer for 2 years at Sony. And in 2018, I feel like, okay, now it's about time I changed my career. So basically in Sony, I was doing more of testing for radio frequency products. And I wanted to do more. I wanted to even go, because I had already experience in development and design from Catrine. So I really loved the job at the time, and I felt like, okay, no, I want to do something else. I want to go into design again. So I left Sony and I went to Philips Electronics in 2018, and up until now, I'm there. Okay, that's just a little autobiography about myself. So, yeah, what do I do at the moment? Basically, like I said earlier on, I'm an RF engineer, radio frequency, high frequency. What we do in Philips, I think you all know Philips. Philips have different products. You know, they make TVs, they make radios. I mean, when I say like FM radios, they make toothbrush, electronic toothbrush that uses wireless technologies and all of that. You probably might have seen different products. You make pressing iron and all of that. But for us, in our in Germany, we do basically what we call medical devices. So we are focusing on medical devices, and the company itself, in the last 10 years, is focusing its attention now on medical products, because, as we all know, the competition in mobile phone businesses, in TV productions, in FM radios and all of that, especially coming from Asia, is a lot. And it's really challenging, especially when it talks in terms of cost of production of a product, starting from design, development, testing, release, and product support. So when you are talking about this thing in Europe, especially like in Western Europe, talking about Germany, France, UK, these are really expensive. Like when you talk about the human capacity that is involved in these things, and how much effort, how much time, and how much cost that goes into the development of this product. So for the company, they thought like, okay, it doesn't really make sense to be competing with countries like China or South Korea or Taiwan, where manpower seems to be cheaper. You know, in India, for example, in these places, manpower seems to be cheaper. Probably the cost of employing one engineer in Germany will pay 6 or 10 engineers in India. So we focus more on places or technologies where competitions are much lesser, and the technology is not that easy to copy. So that's where we are really focusing more on medical products. So for us, so we do medical products. Basically, we do what we call patient monitors. So that's what we design, we develop it, we test it, and we sell to different markets all over the world. So we have our product going to about 153 different markets. So markets means countries here. So if you can see my screen, I will just give you a basic overview of how our technology works. So down there at the lower end of the slide, you see something like MX40, you see bedside monitors, you see patient one transceivers and all of that. So I'm sure if a few of us have been to hospitals before, and we've seen people being given different sensors to be connected to their bodies. We've seen people going through different kinds of operations, X-rays, ECG will be tested, your pressure, your temperature, different signals, different parameters from patients. These are measured in real time. And the information from different patients are basically transferred over a certain network, okay? And these informations are going to be sent to different doctors in different parts of the world. So with our technology, what we do and how this the whole network works. Okay, so we have the devices itself where the informations are gathered, and we have the infrastructures that help to transmit the information that's been gathered through the from the patient monitors. And these communications is done with the help of what we call the access points and the access point controllers. And after that, you have the central monitoring unit where the information are transferred to, and over the air wirelessly the different signals, different informations are passed to the right people, the doctors, the nurses, or whoever is in charge or whoever is interested in this network. So basically that's what we do. I'm just this is the top view of everything, but behind all these things are radio units, the radio boards. Okay, and I'll just try to give you an example of such radio. Okay, so here in the picture you can see a board here. This is just your basic Wi-Fi board you have at home. Okay, this particular one has the so-called M2 technologies. M2 technology helps you to have like a slot in, slot out card-based system, so you can remove it, you can replace it easily as you wish. So this is what I do. This is what I design. Not just for Wi-Fi, we do it for different kind of technologies. We do for IT telemetry services for the US. We do for Japan. We do for Australia. The Europeans have their own standards, and for different continents, we have different radios operating frequencies that we design for them. So basically, it's important to know which markets do we want to go into, and what kind of system do they require there. So that will determine what kind of radios that will be used. Some radios are not allowed. So there are a lot of regulations. Because I'm going to tell you a few more about this kind of the regulation that we have to look into later in the slides. So yeah, so this is an example of wireless radio. So like I mentioned earlier on, we are in our world, we talk about high frequency, and you'll be wondering like, okay, what is high frequency itself? Why do we need high frequency? Why not low frequency? What's the difference between high frequency and low frequency? And if I'm to just explain in a layman's term what low frequency is. I'm speaking here right now, and you can probably the next person in the about 3 meters or 2 meters away from me can hear my voice. I'm transmitting some signals at some frequency, and that is basically a low frequency. I can move at a particular frequency in kilohertz. Okay. And of course, you ask yourself, how far can someone hear my voice? So if I talk, can somebody hear my voice 100 meters away, 1 kilometer away, 10 kilometers away? And of course, not possible. You know why? Because of what we call fading attenuation. So my voice will be attenuated completely as distance increases. So we have two factors that plays a big role here. We have the frequency and we have the distance. In the world of radio frequency, or in the world of high frequency, these are two most important things, because basically for some of us who did physics in secondary school, I'm sure you must have seen this formula called V equals to F lambda. You talk about the velocity of light, you talk about the frequency, and you talk about the wavelength. So this formula, this is where it plays a big role in high frequency world. And where are areas where we presently use high frequency? Quite a lot of them. I just put here a few examples. Like for example, in the first picture to the left, you see 3 different cars. Okay, 3 different cars on 3 different lanes on an express road, and you can see these cars are communicating with one another. So here we are talking about car-to-car communication. In the last presentation, you could hear the Dr. Oyemi talking about big data analysis, talking about autonomous driving, car assistance driving, and things like that. So in the future, not even like in the future, we already have them in the market actually. Like we have now cars that drive themselves. Now we have cars that now communicate with each other, with one another. So what this kind of technology does is it allows like for a lot of security and a lot of safety on our roads, in the sense that you have to, of course, there's something we call human intervention. Human intervention is always very good. It's very important, but we want to design an intelligent system where cars can communicate with each other. If I'm too fast on a particular road, and the other person behind me is driving too slowly, or maybe too fast as well, and it's trying to be tailgating, it's moving too close to me, my car should be able to pass an information to the one behind me and say, hey, you are moving too close to me, please can you reduce your speed? And if we are having a world of autonomous driving, you as a driver, you do not need to do anything. The car should automatically reduce its own speed. Okay, so we're talking about self-assistant driving, and we're talking about autonomous driving. And in this kind of system, what do we have that does this job, that get this job done, is basically radar systems. So in our modern day cars, you will see your cars are equipped with radars in the front wheel, at the back wheel, the headlights. So basically, if you are reversing back, you do not need to be glancing behind you, trying to check, is someone behind me? Is there a person? Is there a tree? Is there an object that's that I'm going to eat at the back? So this kind of system permits you to get warned, to get information, and you can also share information between the two different cars. These are one of the applications of high frequency technology. Okay, so car-to-car communication. On the second slide, you see radio communications in the community. Today we are talking about 5G. We all started from 1G, 2G, 3G, 4G, talking about LTE, you even talk about advanced LTE, and now everyone is talking about 5G. Of course, we are already also talking about 6G. So there's already 6G on, and in a few years it's going to be. So basically, we are talking about different base stations, micro stations, communicating with one another, sending data. You make phone calls, you download movies, and all of that. So these are some of the things that we use in radio communications, and having all these things are using radio technology. We have radio bots everywhere, operating at different frequencies. And of course, there's something that we are looking up. We are already in the world right now, which is the world of IoT. We talk about IoT, the Internet of Things. So basically, we talk about Internet of Things. What does that mean? We are looking towards a world where everything is connected. Every single thing is connected to one another. So your mobile phone is connected to your TV at home. You have your Alexa. You have your Google Talk. So you have your laptop being connected. If you like today, now if I walk into my room and I do not have a Wi-Fi password and I want to connect my PC to my I've already once upon a time I've connected my phone to the same network. I do not need to do anything. My laptop should automatically connect to the internet. So far, the laptop has identified that I'm the rightful owner of the mobile phone. So everything I should be connected to one another. I should be able to switch on my air conditioning system from the office before I come back from work. I should be able to put on my microwave oven, warm my food. I get home, everything is already prepared. That is Internet of Things. So we are living now in the world of Internet of Things. We are living in the world of Internet of everything. But that's what we actually call it, like Internet of everything. So everything connecting to each other. In each of these mobile devices, in each of these stationary devices, in each of these products, there are radio units in them. In fact, it's all about communication. It's all about wireless communications altogether. Okay, so moving down there, you see another picture, which basically is satellite. Satellite, another very popular application of wireless communications. We are talking about a satellite operating the station in the orbit, sending some kind of information to the Earth, and operating at some very, 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 very high frequencies. Of course, I said this slide maybe even makes more sense, or maybe we can even better relate to it, which is basically your microwave oven that you have at home. And when we hear the word microwave, what are we talking about? I mean, probably we are talking about a lot of time we think it's just some imaginary objects, or like we ask ourselves, what's the technology all about? And I just wanted to know tonight, it's also a device operating at some relatively high frequency, basically in 2.4 gigahertz band, and that is what you are using to cook your food. Okay, so it's really important to know this, that whenever you put your food in the microwave oven, that you are emitting some radio frequencies into your food. So it's basically also one of the application areas of wireless radios. There are many other ones that time will not permit me to go into this evening. So just as I mentioned earlier on, all these things are using frequencies. And it's really important to know that not every applications or not every product can operate in this frequency. They are all subdivided into different frequency spectrums. And if you make a product and your product lands in a wrong frequency, you can't go to prison for that. You can't be jailed for that. So it's really important that your product gets into the right frequency spectrum that is allocated for it. And if you look from the left hand side of this picture, you see here, you see your maritime radio navigation system that is operating at a very low frequency, talking about 3 kilohertz to 30 kilohertz. But of course, if you remember very well in your fixes, you remember this formula V equals to F lambda. Okay, that means your velocity of light, or let me say your frequency and your wavelengths are indirectly proportional. So the higher your frequency, the lower your wavelength. Okay, so that means if you go very high in frequency, then the distance at which you can transmit your signal, okay, they reduces. And if you reduce your frequency, that means you can even travel further. So your fading reduces with your frequency. So you can see VL left very low frequency from 100 kilometers to 10 kilometers. From 10 kilometers to 1 kilometer, you see your low frequency. That's where we have our maritime radio navigation system, and we have our AM radio that we probably all familiar with at home, operating at very like medium frequencies. And of course, you can hear different radio stations. They will tell you to tune into a certain frequency at some 99.5 FM radio, 89.1 FM radio, and that's where we have basically the VHF, and you have your UHF up to 3 gigahertz frequency, and of course your satellite is operating at some very high frequency, which is what we call it super high frequencies, from 3 gigahertz to 30 gigahertz, and of course for we have the satellite that operates at very, very, very high.
Yes, can we hear him? I think we lost him shortly again, but that was getting really interesting about radio frequencies and understanding the right frequency. And yeah, I think he's still connected, but we cannot hear him, or I think we just lost him anyway. But yeah, that's been really very interesting learning about frequency. I know a bit about these things, but frequencies are not exactly my thing, but it's been interesting to be able to learn more, and I'm sure that it's going to tie all of his home, so that we can actually those of us that are electrical engineers or interested in this area, we can go on and see it. And it's also interesting to see that things like how all of these things are connected. He is a radio frequency engineer. Dr. Woyemi is an AI engineer, and they were still talking about, there was a part of the video where he shows those cars communicating with each other. He was showing the video, we could see the picture. So you see how engineering is in a way becoming multidisciplinary and it's interconnected. So I'll just hand over back to Engineer Shegun. Engineer Shegun, you have the floor.
Can you hear me now? So, please, if you can hear me, just let me know. So, yeah, so I was basically talking about, we have, like I said, in this frequency are from 24 gigahertz, and right now we are working at for automotive radar, which we call it FMCW radars. Okay, so basically these are radar systems that operate at a very, very, very high frequency, and of course the range, which is actually the distance here that it can cover, is quite relative. I mean, it's quite low, but their accuracy is very, very high. We have to do a lot of signal processing on them. We have to do a lot of Fourier transforms on the systems, on the signals, and with that, you are able to even have a very clear view of whatever is going on with cars. I mean, with the modern day radars that we have, when you look into your cars and you see the kind of pictures that you get from the system, you'll be amazed. You think you are watching a video movie, like it's more like HD movies. So this is what the technology is doing at the moment. So with FMCW, it's operating at 77 gigahertz, and even with the new research that is going on, working at 100 gigahertz, you can be rest assured that in the next few years you will have even much better performance with the radar systems that are used in cars, with all the autonomous driving and all of those things. So yeah, that's that about radio spectrum. So just please kindly take note of this, because this is basically one of the issues that we are having right now in Nigeria. I don't know if anybody have had that kind of experience, or that kind of, maybe you have read in the news when you hear broadcast, the agency, the NBA, I mean the Nigerian Broadcasting Commission, yeah, NBC, telling us that they've banned one radio station from operating because they are probably operating at the wrong frequency, or maybe they didn't get the right license. So all these spectrums are sold. So you have to take note of this. When MTN comes to Nigeria, or Etisalat or Globalcom, they go to the NBC, they buy a frequency, a very tiny part of the spectrum, and they pay a huge amount of money. And this is when this thing begin to make sense to us. You begin to ask yourself, what is frequency altogether? But believe me, just 1 megahertz of frequency can cost you $1 billion. And what this costs in Nigeria is different from what it costs in the US, different from what it costs in the UK, different regulations. So this is a huge thing. This is a huge market. When you go to NBC, or you go to NCC, Nigerian Communication Commission in Abuja, and you hear what it means to buy just a little portion of the spectrum, you'll be amazed. So that's why we really, this is a big, huge business. This is a multi-billion-dollar business, the business of radio spectrum. Okay. So let me just move on briefly into really discussing what the presentation is all about, which is actually product design and development. Okay, so in the next few slides, I'll just be brief you, just to give you an overview of what we do in product development and design at the moment. And so I will just let you know, or I would like to let you know that the product development itself, or product design, it's really an endless loop. And that is what you can see in the picture above. You see, everything starts with an idea. The whole word itself starts with an idea. And that's exactly how also the product that you use today, the mobile phone that you have in your hand, the technology that you are using, it starts with an idea by a certain person, by certain groups of people, and by, of course, by different companies. So we start with research and innovation. So you do research, you do innovation, you say, okay, let's do this thing. Okay, what do? We do a lot of paperwork, and that is the research. We do a lot of putting out together. What do we need? What do we need to produce? Is there a market for this thing? Can they be sold? Do we have competitors? What are our competitors doing in this field? How do we make sure that we design and we develop a better product than what our competitors are doing? So a lot of time is spent on this research and innovation. So after all these things are done, the first thing we do is prototyping. And when I say prototyping, we are not talking about the final product, but we're talking about something that looks like the final product, something that we can work with, a hand-on device that we can begin to do so many things with, testing, or even thinking, or even checking what have we done. Is this thing going to fit in? Is this thing going to be a good design for us? Is this thing going to work as we have planned it? In most cases, they are just mechanical parts. They are just what we called CAD. Dr. Oyemi was speaking the other time about CAD, AutoCAD, and all of those things. So what we do in hardware, in hardware electronics, before we produce anything, we first prototype it. So what do? There? We design it on the paper, we transfer it from the paper to the computer using a lot of different CAD tools. And after that, we prototype it. So we have what we do, 3D printing, right? I'm sure you must have heard of 3D printing. So we go into the lab, we do 3D printing of everything or whatever that we need. Different things that can be printed. We can print artificial hand, we can print our radio boards, we can print, and we try to place them in different parts of the system. Unfortunately for this night, I won't be able to show you some of the pictures from on some of the products I've worked on, because of course for some security reasons, also for some reasons best known to the companies, that I'm not able to share this kind of information. But yeah, but basically from these pictures you can see what this what it may look like. I mean, you can just try to think about it. So that's this prototype. So we are talking about some basic parts that are not real, that see if what we are thinking of is actually good enough, or if we need to modify something. After we have done the prototyping, we go now into design. And what do we do in design? We basically go and put components together on the PC, on the computer. Okay, we source for components. We do not have in Philips, for example, we do not make any of these electronics parts ourselves. We buy them from different companies. So we have different vendors that supply different products. We go to Analog Devices to buy a transistor. We go to Texas Electronics to buy an amplifier. We go to National Instruments to buy a diode or to buy a capacitor. So basically, we source these components from different manufacturers, and they give us also the computer version of this component. So basically, what we are having from them at the beginning in the design phase is not the final product, but just a CAD model of this product that we. So at this point, we're talking now about development. At this point, we have different levels of prototyping. So we start with the first prototype, which is basically the first hand-on hardware. We take it into testing for different things we can think of. So they come up with different test scenario. What can happen? What are the failure modes? What are the reliability issues that we can get from this product? And for just one prototype, for the first prototype, we can spend a lot of time on this. So it goes back to the development. We discover every problem from the first board. We solve all this problem. We go back to our design phase. We change components, we change different parameters, we develop another prototype again. So we usually call this prototype 2. So we have prototype 1, 2, and then we go back to testing, and then we go back to testing, and so we go back to development phase again with the third prototype. We should be fine. If it doesn't, then we're going to do another prototyping. So it continues like that until we have a stable product, until we have a product that we are so confident of, until we have a product that we know that when we sell this to the customer, we're not going to have any issue. And that's why after that, we go into performance engineering. Basically, at performance engineering, we begin to analyze things, begin to see, at this point, we begin to see how the customers are going to deploy this product in their own system. So what are the issues that we can think of And there we'll try to solve this problem. If we need to go back to testing, we'll go back to testing. And if everything is fine, we go back to deployment. And when we say deployment, we now go to really sell this product to the customer, to our client. Our customers are the government of nations. Nigerian government will say they want to into health. And we as a company, we approach them. We say, okay, you need to equip your hospitals with this product. You need an X-ray machine, you need this patient monitor, you need ECG machines, you need this, you need that, you need defibrillators and all of that. And we supply them this product. They're gonna install this product in their hospitals. And of course, in a typical scenario, we send our technicians, not engineers. We send our technicians to these places, to different countries to do these installations. And I really want you to understand this fact that at this from like I started earlier on, everything starts from research and innovation, which actually is the job of an engineer. Prototyping is a job of an engineer. Design is a job of an engineer. Development is a job of an engineer. Testing is a job of an engineer. Performance engineering in most cases is a job of an engineer. But when it comes to deployment, we do not send engineers to deploy products. We send technicians. And because like probably we know we have engineers, we have technicians, we have technologists, and they have different roles that they play. During the development phase, at times we need technicians. If you want to solder some board, you want to solder some components, you want to remove one small component, change it, put another one. I do not need, as an engineer, I do not need to do that. My job as an engineer ends. I do not need to touch any single hardware. The technicians, the technology. Now we are the development phase. The deployment phase, and now our product is in the market. Our product is in the hospital. Our products. Okay, so for our product, we can design a product and we say this product is going to last for 10 years. What that means is that we are only supporting this product for 10 years. If in this life cycle of the product, something goes bad with one of our products, maybe one resistor gets burnt, maybe something happens, we as a company, we are obliged to go and pick this product from the market and replace them. And we're not going to be replacing a single component. We're going to be replacing the whole board, the whole unit. We do not solder anything on our boards. We take the spoiled board, we take it out, and we replace it with a new one. And that's what we do. And this also goes to maintenance phase. It's the same thing at the maintenance phase. So we help them maintain the product. We ask for feedback from them. We ask for how we can improve our product. And you know what? Based on this product, based on the comment that we get from the market, the next version of our product. And this you must have iPhone 4. Before you know it, you see iPhone 5. iPhone 5 is better than iPhone 4. iPhone 6 is better than iPhone 5. 7 is better than 6. 8 is better than 7. 9 is better than 8. 10 is better than 9. And all these iPhone products are coming as new innovations based on customer comments. You see you say tomorrow that the battery gets drained so fast. Okay, the next technology that comes, or the next product that comes to the market, is a product with a robust battery or a robust battery capacity. The next one, you say, okay, the screen is not big enough. The next product that comes to the market is with a bigger screen. Customer next complain that maybe the speed of downloading information, data, and all of that is too slow. Now we go to another manufacturer that produce a better chip for us. So we change our chip. Probably before we were using an Intel chip. Now we can go to Qualcomm and buy a new chip with a better speed, with a better memory capacity, and all of that. And that's why, and you can see this is an endless loop. And that's why you find out that these companies, these manufacturers are in the market forever. They keep making more and more and more based on technologies. These technologies come, new idea comes. With the world of AI that we have today, now all our products are going to be very intelligent, and they have to be also, we have what we call data security. So really our product now have to be secured. So in the last 5-10 years, we didn't have any issue with security. But I can tell you, we've had issues like last year, 2 years ago. Some product from General Electrics and some other companies we got in the US in a situation whereby some hackers, they went into the system and they hacked our information servers such that the doctors did not have access again to any patient information. What does that mean? Patients that are dying, patients that are in intensive care units, doctors cannot monitor their situation. Guess what? A lot of people died. And you know what these people say? Give us $5 billion and then we're going to release your server to you. Give us $10 billion and then we're going to release it. And this is what hackers do these days. That's why our system has to be secured, has to be robust. The security now is a topic. Artificial intelligence is a topic. Okay, so all these things, they play along with one another. So let me quickly, because I don't have a lot of time, I will quickly move to the next slides. And just like I mentioned earlier on, I will just tell you some of the products I've personally worked on. I've worked on different products, but just these two I'm going to tell you. One of the things I mentioned earlier on, like in the beginning, I showed you the life cycle of a product. And one thing I want you to see from this picture is that you should know that to design a robust system, to design a super intelligent, performing a good electronics device, you need time. You need to invest a lot of time. If you take a look at the project to the left, which is K-Bow, this K-Bow is basically an intelligent antenna solution from Katrine, the company that I first worked, and we basically built this product for Ericsson. This is one of the products that we installed in big stadiums. When you go to Manchester Stadium, this is one of our products, and each of these products was actually installed in different stadiums in the UK. Manchester, we did some installation at Barcelona Stadium. We did some of them in Chelsea. In one of the one I participated in last before I left the company was the installation in Manchester. So we have to install this thing in stadiums because when people go into to watch football games, you see 50,000, 70,000 capacity stadium, and everyone is trying to access the internet. Everyone is trying to download data. Everyone is trying to stream at the same time. And guess what happens? In a typical normal system, the network gets overwhelmed and it breaks down, completely dead. So with this system, we are able to amplify our system, our signals, and we're able to intelligently redistribute these systems to different areas where the signals are needed. If at a particular sections of the stadium, there are more people that are downloading, we will give these people more capacity. If we, on the other side where the big men, the owner of the clubs are sitting, these people, they don't do anything, they just watch the games and they only care about their money and their businesses. They don't download much. So we give those people less capacity. So we have a very intelligent system. This kind of system is used also in big shopping malls. We can switch on, switch off this system based on the data traffic that is needed. And you will not believe it. I joined the project in 2014. By the time I joined the project, they had already started 3 years. Okay. And I left the company in 2017. Okay. That's 3 years after. And by the time I left the company, we just started installing this product. So for 6 years, we are developing one product. For 6 good years. You can imagine how much cost this would have taken. You can imagine how much money, how much we pay. These engineers are earning a lot of money. These engineers are investing a lot of their time. And what will you ask me? Why are we spending 6 years to develop just one product? And I will tell you basically that from R&D to design to development, this usually takes only 1 year. In most cases, 1 year, 1.5 years, we have something in our hand, an hardware in our hand. But guess what? The part that takes our time is the testing part. We spend 4 years in testing. If we are not careful, we can even spend more time. We have to test and test and test and test until we are sure that this product is robust, this product is reliable. If you release a product into a market and there's a problem, especially matured markets like American market, European market, and some Asian market like Japan, China, you can't be banned from this market forever. You will not imagine how much a company will lose if they produce a product that is banned in the US. That alone can crash the whole company. Like the company will go down the drain, and that's the end of that company. So we do not joke with quality. We do not joke with standards. We have to test this product to different standards all over the world. We have to take analysis. Unfortunately, in Africa, we do not have any standard. The only country that at the moment has some small standard, something that once in a while we take note of, is South Africa, which they do not have any standard also. They just try to put in one or two information from different standards all over the
I'm not sure. I think we've lost Engineer Shegun again.
Now, can you hear me?
Okay, we can hear you now.
Okay, so I'm sorry. I'm
Type in the comment section
So
if you can hear you.
So basically, so from this slide, what I just want to make us understand is to develop a quality product, we need a lot of time. Like they always say, Rome is not built in a day. So also products are not brought to market in a day. It requires a lot of time and effort. Okay, a lot of time and effort. For every product, we have the software part, we have the hardware part, and all these things must synchronize with one another for us to have a system. And this takes a lot of time. The software engineers are going to develop the software, the hardware engineers are going to develop the hardware, and the test engineers are going to test both the hardware functionalities and the software functionalities, and we're going to do a lot of regulatory testing as well. This takes a lot of time. Product design, product development, it takes a lot of time. Okay, so I'll quickly move to the next slide, which is basically some few tips I would love to share with us as engineers and as potential engineers as well. I just want us to, I took this picture from the internet, and it is, you can see this man here is a Paralympic, okay? His name is called Shuaibu. Shuaibu represented us in the 2012 Olympic in London. And this man is actually disabled, that they will say, but I call him a very able person. This man went into the competition with 57 other Nigerian athletes, and despite his condition, he was the only one that won us a gold in his group, and we all expected other people to perform very well. Unfortunately, they failed, and he did well. And when he was interviewed as a disabled person, how were you able to do it? What happened? He said something. He said, "I didn't start preparing for this competition right now. I started preparing for this competition a long time ago. I started preparing for this competition as far back as 7 years. And this makes us to know that success is not by accident, okay? As an engineer, we can be surprised when an opportunity comes to us, sometimes it comes to us like a shock. But when you are prepared, you grab the opportunity and you make a very good use of it. For me as a person, I can say definitely 100% that Nigerian education puts me on the pedestrian that I am today. Even though a lot of people will not agree that our educational system is good. People will tell you it's shit. I'm sorry to use this word. People will tell you it's crap. People will tell you it's zero. I do not agree with that narrative. The Nigerian educational system is probably one of the most difficult you will go through in the world. And the difficulty is, if you can go through it and you can complete it, it strengthens you. It makes you strong. My first job as an engineer, I look at the job description, I look at myself, I say no. I first laugh at myself because I had no clue. I had no idea. I didn't know jack. But one of the things that I've learned from Nigerian school, one of the things that that came to my mind when I saw the job advertisement, I said, if I can pass Fortran, a programming language that I did in FUTA, which I had no idea when the program started, I can do this. If I can pass MTS 104, which was basically some crazy algebras, some Laplace transforms and Fourier series and all of that, things that I had no idea before I started them, I can also do this. When I got into my class as a master's student, I looked into the lecturer, like the professor. The more I looked at him, the less I saw because I did not understand jack. And by the end of the semester, I wrote the exam and I passed. And these are the things that we have as Nigerians. And these are the things that we learn as Nigerians. We learn this spirit in our schools, and that's the spirit of we move, we forge ahead, no matter what. Nigerians will say we die there. And that word keeps me going at every point in time. There, nothing they happen. We die there. We are not going to die. I always say something. I said, when somebody jump into water, there are only two options. Either you sink or you swim. As we have Nigerians are the only people in this world that I know that they don't want to die. So they swim. They don't go on sink. They swim. We swim. And that episode, that spirit of keep pushing, keep forging ahead. As engineer, you need it. Believe me, a lot of time you go to the office, you come back home with big headache, like your head gets swollen up. And you just ask yourself, do I want to go to the office tomorrow? No, I do not want to, because it's really challenging. But you still have to go. You still have to face these challenges. You still have to do it. So, and that's why it's important as we as engineers to have the spirit of moving ahead, to have the spirit of forging ahead. And the Nigerian education gives you this opportunity. It prepares me for this. It prepares me for the greater challenge. In a classroom of 100 students, they will tell you the Germans will tell you they do not expect more than 40% of the engineers to graduate from school. And you as Nigerians, tell myself, even if now only 1% finish this program, I'm going to be part of them. So these are some of the things that that helps us as Nigerians to move on. So please, it's important that we prepare ourselves for every opportunity that comes out, because you never know when those opportunities will show forth. And when they come, you may not have time to prepare again. You don't prepare when the opportunity is already there. You prepare before the opportunity comes. Okay, so I'll move to the next slide. I will talk about value. Value is everything. You look at, you have here two denominations, 100 naira, $100. You can see these two, they probably are made from the same material. They probably are made with the same paper type, but their values are different. Their values are completely different. Buy me a bottle of Coke with $100. I can buy maybe five, as a Nigerian of today, maybe 500 Cokes. If 100 naira can buy me a shoe, with $100 I can buy 500 shoes. And that shows that the value that we put into things, okay, is very, very important. And that's where I want to challenge us. The thing you do today as a student, as an engineer working in a company, what value do you attach to it? Do you just do this job because because you collect salary from it? I can tell you boldly, there are times that I go to the office and I come back home and I continue working. Nobody asked me to do it. No manager has asked me to work from home. to do anything from home. I go back to the office, I see something that is challenging, I go back home, I do my research, I look for a solution, I go to the office tomorrow, I implement those things. Because why? I'm passionate about what I'm doing. I put value into it. So it's really important that we attach great values to whatever we are doing. As students, are you doing engineering because they told you we find a job easily, or they tell you engineers are rich? And I mean, they tell you some people just do engineering for the pride of it. That should not be your purpose. You need to have a real reason why you are an engineer. And I always tell people, if you are looking for money, don't come to engineering. Go into something else. Go and do forex. Go and do accountancy, management. You will make more money there. But if you are looking forward to adding values to life, I tell people, I do not have to be president before I can add value. As an engineer, I go on the internet, I just do a little research, and I see my name on some product. And I see some product in the market, and I say, I work on this. And that gives me pride. That gives me joy. I'm proud of myself. I'm happy about it. And that's what engineering is all about. We mentioned different names of different engineers forever. Thomas Edison, different of the Albert Einsteins, all of these guys. They were not rich, but they left a footprint in the sand of their time. Please, let's have value for whatever we do, and let us do everything we do with all diligence. That's very important. Like the quote I have here from Warren Buffett, they said, price is what you pay, value is what you get. Every price you pay, hard work you put, the little energy you put in, the little research you do, at the end of the day, they add values to you. In the world of today, nobody cares about your certificate. Nobody cares about your degree. Nobody cares about your first class. Nobody cares about your 2-1. What they care about is the value you can add to their system, to their company. Let me tell you one thing today. I've been working for close to 6 years now in multinational companies, in different ones. Nobody up to today has ever asked me for my certificate. I joined Philips. Up until today, they've never asked me to present my bachelor certificate. They've never ever asked me to present my SSC. They've never asked me to present my master certificate. And I'm working. I put it in my CV. I have this certificate. They believe me. They took me to an interview. I performed well. They believe I can do the job. I'm doing the job. That's what the world that we live in. That's what they care about. The value you can bring to the table. What you can add to their system. Your certificate will not take you anywhere, but the value, the knowledge you have will take you places. I think at this point, I've thought about a few things like, okay, in Nigeria, I mean, I know we can begin to mention different challenges that we face. Like in the beginning of the presentation, I showed you what I was doing when I finished my bachelor. For 1 year, I was selling Indomie. My dream is to become an engineer. I found myself selling Indomie in Nigeria. And you will ask me, how is Indomie related to engineering? And that's some of the challenges that we have in the country, that we do not have the opportunities. And when we have the opportunities, we probably do not have the right resources. We probably do not have the right equipment. We probably don't have the right labs. And at this point, I'm just thinking, how do we as Nigerians, how do we still keep ourselves relevant? How do we still keep ourselves relevant to the system, to the society? How do we still be able to compete with our contemporaries in the other part of the world? And one of the things that I think that really helps me going at that particular point
I don't know if we can still hear him. I think we've lost him, but I think we can see his slide while he's here. I'll just read off it. Professional membership in engineering organizations like HIE, higher degrees and professional courses, communication and idea sharing. So you can actually, look to go for other courses, communication and sharing ideas with engineering friends and associates. I think we talked about that yesterday, collaboration with others, volunteering and all of that. So there are so many things that you can do. You can join professional association, you can go for further studies, and you can at the same time collaborate with your friends to bring up new ideas. Talk about engineering, think about new ideas. Some of these people, inventors that we know everywhere, they're actually started by doing something, thinking about a problem and thinking about how to solve it. So I know, we lost him there. I think he's trying to come back again. But while he's coming back, I'll just say, I think he has said a lot of things. I was just trying to start recapping what he has said. He said, value will take you places. He talked about you can even work for a multinational. He has brought the slide back up. Even while in Nigeria, research, research, and research. Very interesting, very wonderful. Thank you so much, Mr. Engineer Shegun. It's been really wonderful. Okay, somebody's putting a question there. We're going to come to question in a minute, but this has really been very wonderful. And I just want us to, the takeaways from this, he told you his own background, where he's from, and he talked about, how opportunity will always meet preparation, and he talked about what we can do even in Nigeria currently. And one of the profound things that he said, which was funny yesterday when we were saying, sometimes you need to do something else while waiting to even get that perfect engineering job. And he has told us a story how he was sending Indomie for 1 year before he was able to get into, an higher degree and, going on like that. So please, I think it is very important. You can screenshot this, to some of the little things that we can do. He has really talked us through his career, product development, and everything. So it's very wonderful. I'll just go and take the questions now. Engineer Shagun, if you just stop sharing, if you just stay on, then we will come to the questions. You can stop sharing from your hand.
Okay, thank you.
So, stop sharing. Good. So I think there's some questions. First of all, let's say thank you to him for that presentation. That was wonderful. Thank you. Despite and in spite of all the odds on your way, you still give us that very wonderful presentation. I am so impressed. Thank you so much. Thank you so much. And I think there's a question here. I studied mechanical engineering, but currently I work with a microfinance bank. At times I feel ashamed of myself. No, bros, you don't need to. You don't need to. There is no shame in this game. There is no shame in this game. In fact, the fact that they called an engineering conference and you came, that shows that the passion and the desire is there. You just need to find your part now and begin to work on it. So there is no shame in this game. We heard about it yesterday when the speaker was telling us, sometimes you have to do what you have to do to survive, but make sure that that dream doesn't die in your heart. And that's why you're attending a conference like this. Start looking at, okay, the one day, start visualizing that day whereby you will leave that job and what you would like to do next. If you realize what you would like to do next, what is the next, identify what the gaps, what the trends are in the industry. You said you did mechanical engineering. What part of mechanical engineering would you like to go to? Start researching them now. Start preparing yourself. And, start looking for, research, prepare yourself. Look for opportunity to volunteer or to intern while you still do your bank job. And then, one day you're going to be able to make that switch. So please, there is nothing to be ashamed of. You're doing something, you're putting food on your own table or probably on the table of your family. And we quite understand that, we would rather have you employed than not being employed at all. So please, there is no shame in this game. You're doing wonderful. You're doing marvelous. At least you've heard the speakers themselves say. He said he is an RF engineer today, making products with his name on it all over the world. And at one point, he was selling Indomie. So these are really beautiful stories and the resilience of, Nigerian engineers. And, you even mentioned that the resilience, as Nigeria, that's one thing. If somebody asks, what's a Nigerian dream? It is that resilience. We have that resilience to achieve. So before you know it, you are going to be there, my brother. So there is no shame in this game at all. And so does anyone have any other question? Any question for Mr. Engineer Shegun before he goes? Okay, people are saying thank you. Thank you so much. These presentations are great. Thank you. Oh, yes. So I really enjoyed the presentation despite everything. So does anyone have any question for Engineer Shegun? Do you have any question? You can type your question in the comment section, and I'm sure that it will be able to answer those questions. All right, so while we wait for the question to come in, I want to say thank you once again for everyone that stayed even till the end of this. Okay, somebody says, as a materials engineer planning to go for a PhD, what area do you think one can specialize? Oh, somebody says, sorry, I missed yesterday's seminar. Oh, no problem. You're going to get a replay of yesterday's seminar for those people that register. That's the advantage of registering. You're going to get a replay of somebody said, can we download the videos online? Well, we see to that, but you're definitely going to get a replay of the videos. As a materials, in what areas do you think I can specialize in? Okay, there are so many areas you can specialize in materials engineering. I myself am a materials engineer. If you send me an email, um, I'll type my email in the email box because not everyone here is a materials engineer. So we don't want to go into materials engineering again. We talked about it yesterday, but depending on what you like, there's so many areas. There's battery technology, there's physical metallurgy, there is characterization. There's so many things. I'm just going to type my email in the email box and you can send me an email. Let's discuss, let's talk about it. Let's discuss. Somebody said, can you tell us how you made the switch from selling Indomie to landing a multinational offer? Okay, I'll allow Engineer Shegun to just say something there. So maybe something quick, a long story, but maybe something quick, sir.
Yeah, thank you very much. That's a very interesting question. I mean, like I said before, like in life, it's really important that we sustain our dreams. Um, I always tell people, like, people die, but dreams don't die. Okay, I've always had a dream of being an engineer, nothing more, nothing else. Even while I found myself selling Indomie in the market, I was still carrying in my head, at the back of my head, I still felt like I'm an engineer. So when I meet people, when I see my customers in the Ogbete market in Enugu, I will tell them, hey, I'm an engineer, Shegun, but I'm selling Indomie. Will you buy my Indomie? So that was my approach. But then as time went on, I got to know that, oh, I can study for free in Germany. Because my challenge then was to get the funding for my master's, which was tough. I got admission in Australia. They were asking me for $14,000. I got admission in the US. They gave me some 50% scholarship. So it was tough. But then I later found out that I could actually study for free in Germany and still, even alongside when I'm studying, I can still even work. So I grabbed this opportunity. And here I am. I mean, within 3 months of discovering this opportunity, I got an admission, I got a visa, and I was out. And really, I mean, the decision wasn't like I didn't plan it, but everything happened. So dreams came to reality. Selling Indomie wasn't my thing, but it was just a means to getting to where I was going to, because I was able to save a lot of money. I was able to buy materials. I was able to buy data, to use the internet. I was able to go to the cyber cafe. I was able to print my documents. I was able to pay my application fees and all of that. So it helped me to pay all these bills. Okay. And while I was still looking forward to opportunities, I'll keep doing my research. I keep browsing the internet. I keep talking to friends. I got to know about Germany from a friend I met during my NYSC. So please, like I said earlier on, keep the dream alive and keep doing your research. Keep talking to people. Keep asking questions. And of course, at the end of the day, everything's going to work fine. So that was the story of from Indomie to an engineer.
Wow. Wow. You see, that's such a very wonderful story. And I think that's also answered the other person. He had to keep body and soul together in the meantime. But like you said, those money that I was able to get, he used it. You need to be able to research, you need to be able to buy yourself data and all of that. So it's such a very wonderful testimony, wonderful way. And also about, don't let your dreams die. I've been so inspired myself by that. And I hope that inspires us that no matter what you want to do, don't let your dreams die. Somebody is asking for Mr. Shegun's contact. I know you can find him on LinkedIn, but if he wants to drop his email, that's fine. But you can also find him on LinkedIn, on social media. The name is Shegun Adeniji. So yes, please, if you have questions, you can still put your questions in the comment section. I'll get to them shortly. So yes, thank you so much, everyone. It has been wonderful. I know every time I'm hearing the speaker speak, I am happy because, it's not like we're going to import them from places. They are one of us. We are Nigerian engineers together, and you can see their own dreams on how everyone went different ways, different paths. And this is just an example of how all of us too can, from here, make our dreams come true as engineers. And I know that as we make our dreams come true, we'll be able to, support our country, Nigeria, again with this knowledge. Look at all the things he was saying about, selling products and all of that. Today now, if we need a product engineer in Nigeria, you already know who to contact, which is Mr. Shego. So that's just it. So it's been wonderful. Okay, he has dropped his email in the comment section. Please, you can take the email from there. Before I continue, I just want us to say thank you to Mr. Shego. Thank you so much. Despite he's in Nigeria, that's why his network is breaking. You know, so that's why we need engineers to fix our network system. And he has come for an event in Nigeria, and he has just taken the time. You know, it's been a very busy day for him today to present to us. And I really appreciate that it was relentless. You know, and he has told us about that relentless engineering spirit. He was relentless in ensuring that we hear that presentation and it still passed across what they wanted to pass across to us. So it's been okay. The people are saying thank you, Mr. Shego. Everyone is saying thank you, Engineer Shego. It's such a pleasure to have you speak. So I think it's been wonderful. This engineering empowerment pilot program has been really brilliant. When this idea was conceived, the whole idea is that we bring engineers to come and share, because so many times, you know, we see people and we don't think that their realities are our reality. But what this engineering empowerment engineering pilot program has done for us is to, like somebody said, I'm coming to Germany. What it has done for us is has ensured that we can actually, you know, see what other people have done, hear from them, hear about what is happening in our field, and then go on to do great things. So brilliant. Thank you all for everyone that's come to join us. Day one was wonderful. Mr. Kayode Oke spoke to us about career path on Nigeria. He also told his own story. Mrs. Tolulope spoke about the tools that we need, and you know, you heard that again today about the tools that we need, modern tools that we need for as engineers to be able to, you know, fulfill our dreams and also to place ourselves and position ourselves rightly in everything that we do. And then today we started by listening to Dr. Oyemi. That was fantastic, telling us about what the future looks like, right from, you know, industrial revolutions through virtual reality, through, you know, what you can do now and how you can place yourself. And then we came to Mr. Shegun telling us about his background and also how he got into RF, and telling us about product development, you know, just a span of so many wonderful things. And we are really grateful that you all have come to listen to us on Age Reality. Thank you so much for everyone that's come to listen. You'll be hearing more from us. Just ensure that you follow us on all our social media and do on our Facebook page. And also we have your emails. We'll be sending you emails from time to time. In January, we are going to run some competitions and we're going to run an internship program for engineers and students alike. So watch out, watch this space. You're going to hear more from us. So thank you so much. You can write us. I dropped my email yesterday. I've dropped it again today. If you have any further questions, you can check, you can send those questions. Also, you can follow any of the speakers on LinkedIn. You can ask them questions. Just make sure you don't nag them, but I'm sure that they will be ready to answer your questions. You know, just send them questions. Dr. Oyemi has a YouTube channel. You can subscribe to that and everything. So if you have anything, so okay, somebody is saying, please keep in touch. All right, people are saying thank you, and reality. It's our pleasure. We'll be bringing you more programs. Invite your friends. When we're going to send you the link, I think the video will be uploaded on YouTube. When we launch that one, we want you to subscribe and also be able to watch it there. So thank you, everyone. We overshot by 30 minutes today, but I think it was well worth it. Thank you so much. The video today was actually live on on my page, and I'm going to share it on End Reality's page, so you can still share with your friends and everything. But thank you so much. It's been wonderful. It's been amazing to be able to run this conference. It's going to be a yearly conference, and we thank God that despite and despite, we've been able to still make 2020 happen. So I want to say a big thank you to everyone. Oh, somebody said every minute was worth it. Thank you so much. We really appreciate it. You can share our website. People can subscribe on our website after the conference with your friends or your lecturers or anyone that you want them to hear. And we know that, you know, we'll be able to, let's be God's posters of this message. Let's spread it around, everything that you've heard here today. And thank you so much. So go on and do great things. Go on and achieve your dream. Somebody said we next year's conference will be virtual. well, we don't know yet, but most likely to be a mixture of virtual and in-person conference so that everyone can attend. So I'm just going to type the website again, engineeringrealities.org. So you can check us out. So the website is back on the comment page. So please go on to do great things. Go on to make things happen. Follow your dream. Don't let your dream die. No matter what you're doing now, you know, follow your dream. Add value to yourself. Value will bring you money. Value will bring you attention. You know, the Bible says, if you see a man diligent in his work, he will stand before kings. Okay, so let's keep on doing it. Even if you think nobody sees you, you're doing it. You're fulfilling your own dream. So thank you so much. It's been worth every minute. I am so excited and I am so happy. We thank you everyone for staying to the end. God bless you and see you soon. All right. Thank you. Bye. Bye, everyone. I'll still be in the comment section. People that are still typing.